Hi, we're the Missouri University of Science and Technology presenting our submission for the Spring 2022 Concrete Solutions. Our submission is Vaccine Needle Reinforcement, a novel approach to the housing crisis. The United States is currently experiencing a housing crisis in which skyrocketing demand is outpacing a lackluster production. This discrepancy has led to a gap between supply and demand of around 5 million single-family homes. This shortage is caused by a variety of factors, but some of the main ones include labor shortages, as well as various material shortages due to supply chain issues, as well as generally slow rates of production compared to current demand. One way or another, in order for this crisis to ever be solved, we must find a way to increase housing production. And that's what our solution is designed to do.
With 3D concrete printing as a constructive solution to the housing crisis, it is important to recognize its background and advancements. 3D concrete printing is a type of additive manufacturing using concrete to create structures or construction components. With this technology, we are able to configure new shapes without traditional framework, streamline construction, reducing labor, waste, and time, and it's cheaper than wood housing by around 15%. In terms of construction utilizing this technology, we have seen Germany receive its first 3D printed residential building, as shown in the picture in the corner. Of course, as we all know, concrete itself is good when facing compression, but it requires reinforcement to deal with tension, of which there are multiple ways on approaching this, everything from fibers to mesh molds. However, our idea could be a very good solution.
So what we're proposing is to use vaccine needles as a reinforcement in 3D printed concrete. Why would we use vaccine needles? Well, in short, a lot of them are used every year. About 16 billion needles are used per year globally, just during the average year. That equates to 2 million a day in the United States. However, we also see many COVID-19 vaccines and have seen that in the last couple of years. About 554 million doses have been given in the US in total, which would be added on to the average number that was just stated. This creates a lot of waste, so our proposal would be a way to effectively and beneficially reuse these needles, hopefully reducing environmental waste. The good news about vaccine needles is that most hypodermic needles are made of stainless steel, which has ideal properties for reinforcement in concrete.
So a few disposal issues of hypodermic needles. There are currently 3 different methods by which needles are being disposed of. The most common method is incinerating needles at high temperatures. The second method is to autoclave the needles in order to sterilize them and then send them to landfills. The third method is to melt down and remold needles or otherwise recycle them. Incineration and landfills are wasteful methods that can be environmentally hazardous. Therefore, using needles as reinforcement is a new method of recycling and would be very beneficial to the environment.
So there are a couple of ways that we could implement this particular needle reinforcement, which we have 2 listed here. The first is a mix approach, where implementation would be by pre-mixing needles into the concrete prior to printing. The good thing about this is it would offer a hazard-free way to implement the needles as a reinforcement, because there would be little to no contact by any workers that were present to contact with those needles. It would also give a multi-directional reinforcement in the concrete for benefits for tension in all directions. The other approach that we thought of would be what we call the nail gun approach, where implementation would be by essentially shooting needles into the concrete as it's being printed. So it would require an additional apparatus or some additional machinery for the printer to be able to implement. But the good news is it would be able to give a directional control of the reinforcement if you wanted to be able to control or knew how the concrete was going to be used and wanted to be able to have more control over the reinforcement.
So a few of the benefits and challenges. For benefits, stainless steel offers good corrosion resistance and there is current research and use of stainless steel in industry to depend on. Another one is that our method reduces environmental impact of needle waste. Needles are often found washed up on beaches and polluting other waterways. Recycling them would prevent any further environmental harm. A third benefit is this provides a cost-effective solution to part of the housing crisis, where you can use recycled fiber reinforcement in your concrete. So a few of the challenges. So using hypodermic needles means that you must have no human contact with the printing process due to the needles being biohazardous. But our method utilizes 3D printing, and this offers an automated environment which generally has very little human contact. So a second challenge would be 3D printing must evolve to be more feasible on large scale use in order to benefit the housing issue. This would be more research into different type of methods and funding for 3D printing. A third challenge would be more research is needed in how the shape and gauge size of needles would actually affect the properties of concrete.
In summary, vaccine needles could be a possible reinforcement for 3D printed concrete. This solution also helps solve labor and supply shortages leading to the housing crisis in the United States. The impacts include reducing needle waste, helping build stronger structures and foundations for homes, aiding in solving the housing crisis through automation. This has been our submission for the ACI Spring 2022 Concrete Solutions from Missouri University of Science and Technology. Thank you.